Hello, geometry. So you should have this paper in front of you right now with some notes on it. It says day 2 because day 1 was yesterday, and we talked about the angle-angle similarity. So let me just write that real quick. Day 1, we talked about angle-angle. Today is day 2, and we are going to talk about the side-side similarity. And if you remember, we talked about side-side-side congruency a couple chapters back, but this is similarity. And we're also going to talk about the side-angle-side similarity. Again, we talked about that one with congruency a couple chapters back. So, for the first one, side-side-side, here is the idea. If all three sides of a triangle, this is all about triangles, no other shapes, just triangles for now. If all three sides of a triangle are in proportion with the three sides of a second triangle, the triangles are similar. Done. So if you can figure out that the scale factor for all of the sides is the same, then you are good to go. So for example, just real quick, if this was 1, 2, and 3, just making up numbers here, and this guy was 3, 6, and 9, you can say, oh, look at that, my scale factor is 1 to 3 all the way around. Therefore, these are in proportion, these are similar triangles. Easy as that. You make sure you check all of them, though. Make sure you check all of them. And again, if we know they're similar, we automatically know that the angles have to be the same. So if we know the side lengths, we can then know all three angles are congruent. There we go. Next one, the side angle side similarity. Just like with side angle side congruency, it has to be, let me draw this here, if I have that triangle compared to this littler guy, it has to be side, the included angle, side. Side, included angle, side. It can't be two sides and like a random angle over here. It has to be the one that connects the two sides. So, here's the idea. If we know that two sides of one triangle are in proportion to the two corresponding sides of a second triangle, and that the included angles are congruent, because again, even if they're similar, those angles are going to be congruent, then the triangles are similar. And that has to deal with the fact that if I have these two side lengths that are opening at this wide of an angle, there's only one other option for this side length, really. So it goes back to side, side, side then. If these guys are in proportion to these guys, the third one's going to be in proportion as well. That's the idea there. So those are our notes today. Make sure you have those written down. The next 4 examples are all examples of that. And they're mixed up. So some are side, 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 some are side, angle, side. So let's take a look at these. So to determine whether the triangles are similar, it's possible they are not. If they are, write a similarity statement. So triangle blah, blah, blah is similar to triangle blah, blah, blah. Explain your reasoning. So give me a reason, and for that one, I want you to tell me it's side, side, side. It's side, angle, side. Something like that. And if you want to throw in the scale factor that you found, that's a good place to do it as well. So let's take a look at the first one, letter A. Here's the deal for this one. You always want to look at the short side compared to the short side, the long side compared to the long side, all of that good stuff. So, first identify in this triangle, 5 here is my short side. So in my slightly larger triangle, the 12.5 is my short side. So if these triangles are similar, they are going to be the corresponding sides. That's key here. I also look for my longest side. In this case, 8 is my longest side. In my slightly bigger triangle, 20 is my longest side. That leaves me with the 6 and the 15 going together as well. So let's check the similarity. if these are indeed similar, I should be able to say that 8, well, let me do it the other way. Let me say 20 is to 8, that proportion, should match the 12.5 to 5. And that should also match the 15 to 6. It should, right? It should be all the same. So, sorry, had to get the puppy dog out of something. There we go. So, real quick, these should all be the same ratio, the same scale factor. When I simplify all of these, I get that the ratio is 5 to 2 if I simplify. Or if you go for the direct decimal, that is 2.5. So my scale factor is that this triangle is 2.5 times bigger than my smaller triangle. And since that is true all the way around, I can say by side, 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 and I'm going to write my similarity statement next. By side, 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 triangle PQR is similar to triangle, now make sure you write the correct order here, PQR. That went across my medium side and then down my short side. So medium side, we're going to do STR. There we go. So that is for letter A. Letter B, this one here, I see 8 and 4, 10 and 5. But here's the deal. I have my triangle, let me draw this here. My first triangle is this guy, right there. My larger triangle is this guy, right here. So for that large triangle, my side length is not 4, it's 12, the 8 and the 4. My diagonal side length here is not 5, it's 15. So just keep that in mind. That one's 12, that one's 15. So comparing to the little red triangle there, if these are similar, I should be able to say that 8 is to 12, so short red side compared to short blue side. 8 is to 12 should be the same as 10 to 15. Diagonal red to diagonal blue should be the same. Those are my two side lengths, and then I see that angle A is shared on these triangles, so it has to be congruent to itself. So that's easy enough, that part's done. If I can do these two sides, make sure they're in proportion, I can say this is side angle side and that they're similar. So let's check these for a second. When I simplify both of these, I get 2/3, or if you go straight for the decimal, 0.6 repeating. And that works for both of these. Therefore, I can say by side angle side, triangle AEF is similar to triangle ACB. There we go. Alrighty. So next to here, I would like you to pause the video and try these two on your own. And then come back to the video and see if you got them correct. So go ahead and pause the video now. And let's take a look at our answers. This one, I see that they've given me all 3 side lengths. So I'm thinking side, side, side will be appropriate here. And what I'm going to do is just check all of the side lengths, make sure their proportions are good to go. Make sure to compare your longs, your shorts, and your mediums. So here we go. My short side is 8. My short side over here is 6. So 8 to 6, that's one of my scale factor pieces, maybe, if they are similar. My medium pieces are 12 and 9, so 12 to 9 should also work. And then my long side is 16 to 12 over here. When I simplify though, when I simplify, I get 4/3 all the way around. Therefore, I can say by side, 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 triangle JLK is similar to triangle. Again, that one, the first one, you can say however you want to, really, just pick your 3 sides. But the other one, you have to make sure that you are in the right order. So JLK, I went down my medium side over to my short. So down my medium side over to my short, that's going to be QMP. There we go. My last one. Again, make sure you've tried this before the video continues. I see that I have crisscrossing lines, so I see that this angle is congruent to that angle because they are vertical angles. So, and I also see that they didn't give me TZ or XY, so I'm thinking that side angle side will be able to help me here. But I have to prove that the side lengths are in proportion to each other. Again, go for the shorter side compared to the other short side. 10 is my short side compared to 11, which is my longer side. In my slightly bigger triangle, 20 is my short side, 22 is my long side. So make sure you are comparing the correct things. If you are not lining those up, it will not work out for you. So make sure you're lined up correctly there. My short side is 10 compared to 20. That scale factor should be the same as my long side 11 compared to my larger triangle, long side 22. And I see I'm going to get a scale factor of 1/2 out of both of those. Therefore, by side angle side, triangle TWZ is similar to triangle. Now let's see here, TWZ. I went down my short side and then down my long side. Short side would be Y, W, down the long side, X. There we go. So there is your review. There are your notes. Make sure you pause the video as you need to look at these notes. Make sure you have them all written down, and then you will have an assignment out of the book to try these.